Welcome, everybody. I'm just putting together a quick little solution set to some of these problems just because I'm not here. And I know some of them are going to feel kind of new, so I want to introduce them and kind of walk through it. So I'm going to do them in order. So if you are looking for a specific problem, just fast forward till you find the one you need. So we're going to do number one. A 400 kilogram car rounds a corner at 6. So rounds a corner. If the corner is a radius of 30, what's the acceleration? Let's do a quick review of the equations. Centripetal acceleration is v squared over r, and the centripetal forces will be mv squared over r. That is a v up top there. I should draw that a little more clearly. Sorry, guys. So the first part, what's the acceleration? So the acceleration in this one is 6 squared over 30. So the acceleration is going to be 1.2 meters per second squared. Then over here, you could say the force equals mass times velocity squared over radius. So your force is 480 newtons. I also, every time I do this, some students are like, couldn't I just do F net equals ma? Yes, you got 400 times 1.2. You get the exact same answer, 480 newtons. I think what's important to this is, yes, it's accelerating. It's not speeding up the car. It's turning the car. If you think about the nose of the car, it's turning. It's getting changed. And so that's why there's a acceleration. All right, number two. Number two. Come on, pen. All right, number two. We've got a seagull flies in a circle of radius 6. If it experiences 400 newtons of centripetal force, how fast is it going? So force equals mv squared over r. It feels 400 newtons. Its mass is 2. And its radius is 6. So what I got to do first is move that 6 up. So I get 2400 equals 2v squared. Then divide both sides by 2. I get v squared equals 1200. And I take the square root of 1200. And I have no idea what that is. Therefore, handy dandy calculator. Stop using your phones, guys. I'm telling you. Now is the chance to stop using your phones. Today could be the day. I get 34.6. All right. So the velocity of the seagull is 34.6 meters per second, which is about 70 miles an hour. That is amazing. Okay. Sorry, didn't mean to geek out. I'll tone it down. All right. So number 3. Stopper. So this is a stopper lab. If you were not here for the lab, this is the most confusing question you've ever seen. Because you're like, doesn't even make sense what you're asking. So what we had is we had a string attached, and we had a little stopper that moved around in a circle. And then the string was attached to, let me actually draw it semi-accurate. We had like a little tube, it was a pen tube, and the string went through the tube. And at the bottom, there was, we had a weight hanging from it. And you guys held this with your hand right here, and you swung it around, okay? So this guy right here feels the centripetal force. So it's mv squared over r. Now, it tells us what the mass is, 50 grams, so 0.050 kilograms. Got to get everything into kilograms, meters, and seconds. Swung around a circle of radius, 0.44 meters. I got to get everything into meters, okay? It took 2 seconds to go around 6 times. Okay, let's think about that. So it did not give us velocity. So whenever you're in a situation they don't give you velocity, one of the strategies is to do 2 pi r over time. 2 pi r is 0.44, and the time is, it takes 2 seconds to go 6 times. So if I do 2 seconds divided by 6, I get 0.33 seconds. So I'm going to get what my velocity is, just so I have a number. I get 8.37. I'm just going to write that down. Okay, and then if I go here and put that in, I now can get my force. Let's get that for you, okay? Divided by 0.44. My force, hopefully I plug this in right, 64 3, yeah, 7.96. So I'm scared because I rounded a little bit. So let's just round that to about 8 newtons. Okay, I'm right around there. Number 3. Okay, let's get number 4 up here. Let's see what's going on with number 4. Number 4, child is on a merry-go-round. Ooh, okay. The kid can only apply. Oh, skip number 4. Let's do number 5. Child is on a merry-go-round play structure. Okay. The max the kid can hold on is 200. That's all the kid can do. How fast can the merry-go-round before he slips off? So force equals mv squared over r. Ooh, somebody's at my door. And so the max the kid can do is 200. So the kid's mass is 88. Don't know what v is, but my r is 1.9. So math steps. I'm going to multiply both sides by 1.9. So it gets 200 times 1.9. I get 380 equals 88 v squared. Next thing I need to do is divide both sides by 88. I'm going to slow down talking. So I get v squared equals 4.32. Square root, I get v is 2.1. There you go. It's the fastest this kid can go. The kid really wanted to go faster. All right, let's get down to number 6 here. Okay, we're gonna get into some new ideas here. I really wish I was here to go with these with you, but hopefully this video helps as a way to kind of slow stuff down. So now, number 6. Car rounds a corner at 12. Sound familiar? What friction must exist to make the corner if the radius is 48? So force is mv squared over r. So I want to know how much friction force needs to be there. So the mass is 500, the velocity is 12, and the radius is 48. So the force that we need is 1,500 newtons. If 1,500 newtons is not there, that car will not make that corner, and it'll slide off and go straight line. Okay. All right. So the next question I didn't put a number with because it's just a fun one. Corners and friction. A car runs a corner. Okay, a car runs a corner. It's the top-down view. And corners and friction. Okay. The radius is 95 meters. Coefficient of friction is 0.95. Ooh. Can I see what's going on here? They did not tell us even what the mass of the car is. Okay, so you have a couple options. Option 1 is because you put in just a mass of like 1 or 100. Totally fine. You can totally do that. What's the fastest the car could go? So our goal is velocity. Okay. So force equals mv squared over r. Well, let's just write down what we got. We want to know velocity, so that's okay that that's there. Radius, they told me, was 95. Okay, we're doing okay. Now let's think, what force causes this car to go in a circle? Well, that is the force due to friction. I'm just going to write that down. Force due to friction, okay? And now I'm going to plug in, what is the equation for force due to friction? Remember the fun equation? Okay. So it was mu times normal force. Well, the car's normal force is going to equal mg when it's on the road. And look at this, how on both sides. See how the m's are there? Now remember, if you plugged in an m, just a number there. But look at what these two numbers do. The masses cancel, meaning the mass doesn't matter. It doesn't matter if it's a heavy car or a light car, as long as all we need to know is the coefficient of friction, which is pretty cool. So I got 0.95 times 10 equals v squared over 95. So I got v squared equals 0.95 times 10. Ooh, times 95. So we got v squared equals, I'm going to solve this one out, 903. I'm going to round a little. Well, if v squared equals 903, that means v equals the square root of 903. I'm just going to take the square root, and I get 30. Pretty close, so I'm just going to round, okay? That's the fastest the car can go. And if you look, right, you'll never see, when you look at those corners, it won't be like, if you're this heavy, this is your speed. Instead, they just say, this is the speed for every car through this corner. All right, Derek. Come back. We've got another one of those coming up. Number 10, we're going to come back to that. So Derek is riding number 8. And snowboard makes a turn. The radius of the turn is 10, moves to 12. What acceleration? So acceleration is v squared over r. So the acceleration is just 12 squared over 10, which is 144 over 10, which is 14.4 meters per second squared. Now, think about this. Normally, like if I fell off a building or, wow, that sounded really bad. Okay, so normally, right, if I'm accelerating due to gravity, that's better. It's just 10. So if you notice, this acceleration the snowboarder is feeling is greater than what gravity is doing, which is kind of cool. So what we call is, when we have this, we call it a G. Okay, so let's get into number 9. In case you just joined us, number 9. This is a weird question. So Brina and Michaela are riding an elephant in Africa. This elephant suddenly makes a hard turn. They experience 3 Gs. Well, let's talk about what that is. So 3 Gs, what that means is 30 meters per second squared, because 1 G is 10 meters per second squared. And so 3 Gs means you're pulling 30 meters per second squared. Okay, what's the radius? So acceleration is v squared over r. So my acceleration is going to be 30. And, I think we know the velocity in this one, don't we? 8. So 8 squared over r. I have this one here because this is a math mistake that is really common. To get r, I got to get r on top. So if I multiply both sides by r, I get 30r equals 8 squared. Now to get r by itself, I need to divide by 30. So r is 8 squared, which is 64 over 30. So 64 over 30, 2.1. Translation, the elephant took a very sharp corner. All right, lots on that one. All right. Number 9, number 10. Number 10. So this is, you have a car, you have a coefficient of friction. Let me just write it as U, just so it's clear. So coefficient of friction of 0.95. What is the tightest corner they can make? So we've got force equals mv squared over r. And if you take a tight corner, that's a force of friction equals mv squared over r. Okay, force of friction is mu times normal, which equals mv squared over r. And normal force equals mg. Okay, so now I'm going to come back up here. So I got mu is 0.95 times m. Let's plug it in. They gave it to me, right? V squared, 30 over r. R's on the bottom. I got to get the r on the top. So I'm going to multiply both sides by r. 0.95. I'm going to show my work. I really wanted to multiply these, but I didn't want to skip a step. So I'm going to simplify the left numbers and the right numbers, okay? So the left numbers is r times 4750. Let's just simplify the right numbers. I got 500 times 30 squared. 450,000. Okay, so the radius of 4750 equals 450,000,030. So I get a radius of, wow, I got to divide both sides. I get 95 meters. Notice that's the tightest corner you can take is 95 meters. So I'm going to give you a visual, right? You've seen these, right? These are called clover leaves. Think about how big they are, why they're so big, right? They're so big because as you're going at highway speeds, our tires can only do so much. And so I have to have these big radiuses when I'm going at those speeds. 30 meters per second is about highway speed. So, all right, we're going to do number 11, and this is it. Okay, number 11, 20-kilogram child is in a car seat. Oh, good job. And experiencing an acceleration of 35. Okay, tight corner, something's going on, right? Whoa. If the corner has a radius of 12, what speed is it moving at? So I look for my relationship of A, V, and R. So A is V squared over R. So I got 35 equals V squared over 12. I want to get V by itself, so I'm going to leave it up top. I'm going to multiply both sides by 12, so 35 times 12 is 420. So 420 equals V squared. So V is the square root of that number. 20.5. There it is. Found my pen. Units, meters per second. 20.5. What speed is the car moving at? 20.5 meters per second. Sorry, my nose is tickling.